This conference will now be recorded.
Now tell me, what is the major differences between arrays and linked list? When looking into insertion, okay, size doesn't matter. Now tell about insertion and deletion. Which one is better in insertion and deletion? Arrays or linked list? Okay, very good. No, it is linked list. Linked list is very good when compared, very good in insertion and deletion when compared to arrays, right? So which one is better when searching is the scenario? Why? Why searching in arrays is easier than linked list? I'm not able to hear Ram Prabha. Yeah, actually, searching is very easier in linked list in arrays only due to the index value, right? Just because we have index, we will be able to access it directly, as Karan is saying. Very good answers. Thank you for your response. And in today's class, we'll be continuing about linked list. I'm just going to point out the concept alone. You are going to write code for me today, okay? Because we have clearly explained how to access structure, how to access structure pointers. Now, why do we pass double pointers? What is the difference between single pointers? When are we going to pass double pointers? All these concepts were explained by me during our previous section. So in today's session, you are going to help me write out the code. So how many memories will be allocated for a structure definition, people? How many bytes of memory will be allocated for a structure definition of a node? I'm waiting for your answers. 16, 2. So let me write the structure definition. Please tell me if the screen is not visible. Stack node. So it will end up with semicolon. So a node will be having two parts, right? So what are those? Data part. Assuming my data part as integer, I'm using int data. So as I told you, next is a pointer variable that will be pointing to the address of the next node. So it is just pointing to a node again. So it is a self-referential structure, right? Now for this particular structure definition, how many bytes of memory will be allocated? Four. Then 4, 16. Okay. For this structure definition, 4 bytes of memory will be allocated, right? I'm clearly telling you it is structure definition. So since it is a structure definition, no memory byte allocation will take place at this particular stage. Okay. So when we are trying to create one variable inside main, so after the declaration of a structure variable, only memory will be allocated. So these are referred to as structure members. Okay. This particular snippet or small piece of code is referred to as structure definition. So no bytes of memory will be allocated for this structure definition. So as soon as I create my structure variable, memory allocation will take place. So in C, whenever you declare a variable only, memory allocation will take place in all the scenarios. Okay. So I'm going to declare variables. How I'm going to declare variables? So struct is my keyword, node is my structure name. So I'm going to declare a structure pointer called head. Okay, so head is a structure pointer variable. So once a structure variable is created, as you all told, 4 bytes of memory will be allocated, right? So this is how memory allocation will take place. Remember people, only after the declaration of any variable, memory allocation will take place, right? So this is how we declare variables, right? So as I told you already, this particular head will be giving you the starting address of a starting point of a node. Okay, only if you go to head will tell you the address of the first node. From first node we'll be reaching to the second node. Likewise, it will be reaching till you see a null value, right? So it will be like the starting address. Okay, so as we all know, it is also a pointer variable. So each pointer variable will be having how many bytes of memory? Occupying 2 bytes of memory. So head here will be occupying 2 bytes of memory. Okay, it will be having its own address also. So let us assume the address as 11x, triple one x. This particular address will also be stored in a hexadecimal format. For our clear understanding, I have used a value here. Okay, so as of now, we have not uh, we have not chosen the value, or we have not created a memory for a node. So initially the head content of the head will be equal to null. Okay, so now what will be the value of head? It will be null. Okay, so let us assume I have two more nodes here. Okay, with the address 100. Okay, one more node with the address 200, right? As you all know, this will be the last node. So last node's next part will always be null. Okay, so this pointer variable will be pointing to 200. Head will be pointing to the first node. So let us assume the value as 3 and this as 5. Yes, so this is the uh, logical view which I'm going to use for illustration. Hope it is visible, right? Are you facing any difficulties in in seeing the screen? Okay. Okay. So now we are going to delete a node. We are going to see deletions as I've told you. So deletion. So we'll be having these type of deletions. So deleting at the beginning, deleting at the end, and deleting a node at given position. Okay. So whatever we have seen in insertion should be applied for deletion here. So deletion at the beginning. So let us consider my scenario. Yeah, yeah. So I have to delete this particular first node, which is having a value 3. Okay. So if I have to delete this particular first node, what all changes should I do here? No, I should replace the heads content. As the node is created, the heads content will be initially 100. Right. That is why it is pointing to the first node. Now, voice is not clear. Or you people not hearing properly? People, let me know. Or you're hearing me? It's clear. Okay. So I'm continuing with the deletion part. Okay, thank you. So I'm continuing with the deletion part. So if this is the first node, if 3 is the first node to be deleted, what all changes should I make? I should make my head point to this node, right? So what should I do? Where will I find this node's address 200? In this particular part, right? So what will I do? I will be needing a temporary variable assigned with the address of head. Okay. So let us write code for that. So I'm going to perform deletion. So delete at the beginning. Okay. Will be my routine name. So as I told you already, whenever there is a change in the logical structure of your node, of your representation, then we'll be passing double pointers. Okay. So on deletion, there will be change in the logical structure of your node's memory. So what I'm doing, I'm passing address of head. So address of head will be passed. In earlier, when dealing with insertion, we also passed the address data part, right? While inserting, you'll be needing a data part, whereas while deleting, we don't need it. There is no use of passing data part here. So I'm just passing the address of head. Okay. Now let us try writing a routine for deleting at the beginning. Okay. So void delete underscore beginning. What we have passed? We have passed the address of a node. Okay. So here head is itself a pointer variable. So whenever we pass a pointer variable, we need whenever we pass address, we need a pointer variable to hold, right? So structure a pointer variable. So here head is again a pointer variable. So double pointer should be used. I'm using q variable for representing or for holding the address of head. So q will be now holding 111x, right? So we can find null node and point to the last address. What is the use of finding null node, Karan? We do not want to traverse here because we are just finding the beginning node. Whenever we are deleting at the last, only we have to find it. We have to traverse and find the null node. Okay, so we'll proceed with the deletion part. So, as I've already told you, I will be needing a temporary variable to keep track of my nodes. Okay, so let us now declare a temporary variable temp, right? So that temporary variable will be holding what? My first node's address, that is the head address, that is 100. Okay, now temp will be pointing where? To my first node. My temp will be pointing to the first node now. Okay, so what is the logic? I should make my second node as the first node now. So where will I find my second node's address? In this part, right? In this part, which is pointed by temp of next. Okay, so temp of next. Now I will be assigning my temp of next, which is now 200, to where? To the heads content, which is nothing but star q. Now this particular 100 is replaced by 200. So I have made my head to point to the 200 now, which is the first node now. So as this particular node is removed, we are dealing with dynamic memory allocation. So whenever we are having a free space, that should be we are having an unused space, we have to free that memory space. So we have to perform free. Free is a function. We have to pass an argument. So now what argument we should pass? We should pass this temporary variable. Okay, because temp is pointing to this node now. So I have to clear the memory space pointed by temp. Okay, so this is the routine for deletion at the beginning. Very simple. So you just wanted to find the change the length of the head. Okay, and make it point to the second node. So where will you find the second node's address? It will be present in the first node's next part. So to keep track of the first node, I will be needing an additional variable called temp. Okay. So this is the logic behind delete at the beginning. I hope this logic is very clear, right? Are you people understanding what I'm telling now? Are you able to understand? I'm waiting for some response. Are you all understanding this concept? Yes. Thank you, people. Thank you for your response. So we'll see this animation now. So deleting at the beginning. Whatever I've explained now was showed in the animation. So now I will be needing a temporary variable to keep track of my first node. Okay. Temp is pointing to the first node now. So I should make my head to point to the second node. That can be done by just changing the links. Okay, that can be done by changing the link. So this node's address, second node's address is present in this particular variable, which is referred by temp of next. So I'll just change temp of next as my address of head. That's all. So this is the logic. This is the logical structure after deleting the first node. Code. This is the code for that. I have written the code already. Okay. Okay. Now we are moving on to delete at the end. Okay. So I've already told you for each and every scenario, if each and every routine that you do, you have to put the logical view first. You have to draw the representation, find out the logic, and write code for that. Okay. So how to delete the node at the end? What will be the procedure? Look at this particular representation. I'll erase everything. So now look at this particular representation. Deleting at the end. End means you have to find the last node. Okay. So if you have to find the last node, that can be found with the help of null. Okay. So for that, you have to start from the starting address, move to the next node, move to the next node, and find the null part. Okay. So this is the first thing. So find the last node. That should be done only with the help of traversal. Traverse panni, you should find the last node. Last node find panni, if you're trying to delete this, okay, then this particular node which I'm pointing now with the value 30 will become your last node. Okay. So if I have only one variable called temp and that is used to find the last node, my temp will be here. Okay, so I'll delete my temp also. Then how will I keep track of this particular before node, previous node of temp? So in this case, I will be having an additional variable. I will be needing an additional variable to keep track of my previous node. Okay, so I'll be needing two variables. One is temporary variable, for another one is previous variable. Okay. Temporary variable will be checking for null condition and previous variable will be keeping track of the previous node of temp. Okay. Only with the help of previous node, I will be able to do all my corrections over here. Okay. Let us check. Let us now write a code to know the logic here. Right. So here also, I'll erase all these things. Okay. So what are we trying to do here? We are performing delete underscore end. We are performing delete underscore end. I'm passing what? Address of head here. Okay. So I'm going to write the routine. Just copy pasting it. So delete underscore end, END. People, as I've already told you, the number of minutes of your stay is being monitored. So please stay for the whole class. I also this saw the report of your binary programming. You have not done the data structures part of insertion and all. I've seen only 2 or 3 persons who have solved the code. Others have not done. Navindri sir has insisted to you to do the code. He'll be monitoring your code report daily. So please do the code. By today, I want everyone to complete the deletion linked list part in your binary tool. Okay. So tomorrow when we take report, if we find you without the code, then you have to face the consequences. Okay. So we have taught you the concepts. Then it is your work to solve in the binary platform. When the report was tracked, we found that you have not done the coding part in the binary tool. So I request all of you to do the coding part. Okay. So we'll proceed with the deletion at the end now. So as I've already told you, we will be needing additional variables for keeping track of the nodes. So stack node star temp to hold the address of the first node, and for the traversal part, I also need a previous variable to keep track of the previous node of temp. Okay, this is we are dealing with sequential access. So temporary variable will be assigned with the address of the assigned with the content of the first node. I'll I'll better draw the representation over here, so it will be very clear for me to explain you. Let us assume that we have 3 nodes in memory. The last node is represented with the null value. Each node will be having its own address. So this is the head pointer. So initial value of head will be 100. This referring to be pointing to the first node. Let us assume the value of 3, 4, and 5. This will be referring to here, and this will be referring to here. If you want, I can write the address for explanation part. Yes. So I'm done with my logical representation. As I told you already, my temporary variable will be allowing me to start the process. So now my temp will be referring to my first node, TEMP, right? It will be referring to my first node. As I've already told you, we are here to traverse. Okay. Initially, we do not know the previous value because previous value of temp, we don't have any node at this particular position. Okay. So that will be equal to what? Null value. So we should traverse here and find the last value null. Okay. So for that we will be needing a loop. So I will always keep track of temp of next. I'll check whether it is not equal to null. Okay. Whenever it is equal to null, my loop will be terminated. Okay. So I'll write code here. So what I'm doing, I'll check temp. Initially, this particular line will be checking temp of next, which is nothing but 200. It is not equal to null. Yes, it is true. Then it will be getting inside the loop. So loop, what should I do? I should make my temp to point to the next node. That can be done with the help of assigning temp of next. Temp of next is nothing but now it's equal to 200. That will be assigned to my temporary variable temp. Okay. I hope this is clear. Okay, now I'm just moving my temporary part from first node to my second node, right? This particular statement is making me to move to the next node. So, but as I told you, I should keep track of this particular node. So before moving to the next node, I should have my previous pointed to temp. Okay. So let me explain you now. So while temp is initially pointing to the first node, okay, this is the temp, okay. So temp of next not equal to null. So I'm checking whether temp of next is equal to 200. It is not equal to null. Condition true. So before making my temp to point to the next node, I'm just assign my temp value to previous. So now my previous pointer, what is pointing to my first node, and my temporary pointer will be moved from the first node to the second node. Okay. Again, what will I do? My loop will be repeated, right? Now my temp is pointing to 200. Okay, I'll check whether temp of next. Temp of next is equal to 300. It is not equal to null. The condition is true. Now my previous will be assigned to 200. So my previous will be pointing to the second node. After making previous to point to the second node, my temp will be moving from this particular place to the third node. Temp is equal to temp of next. So temp will be pointing to 300. Now check temp of next. Temp of next not equal to null. No, it is equal to null. So what will happen? This particular routine of loop will be terminated. So I have to change the links alone. So I have found the next node, last node. So now what should I do? I should delete this particular last node. Okay. If I delete this particular last node, my previous node should be made as the next part should be made as the null value. So how will I do that? So what should I do? I should make my previous of next, okay, null. Okay, which means this particular 300 will be now erased and it will be replaced with null. So I have an unused variable over here, unused memory space over here. So what is my work? I have to free. So what should I free? You have to free the memory space which is pointed by temp now. Okay, now this particular memory space will be freed. That's all. So remember people, whenever you have a case to write a routine to point to the end node, you have to traverse. For the traversal you need a loop. Okay, so it isn't just because we are dealing with sequential access, we will be needing a temporary variable to start the process of traversal from the beginning. Okay, that is the temporary variable. So to keep track of the previous variable, previous node of temp, we have an additional pointer. So we need 2 pointers for doing this process. Okay. So we need to find the last node, then change the links, then free the memory space. That's all. Right. So this is the logic behind insertion, deletion at the end. I hope this is clear, right? It is shown in this particular animation. So initially temporary variable will be pointing to my first node, my previous to null. Okay, what will I do? When my previous is pointing to my first node, my temporary variable will move. So when my temporary variable is finding the last node called null, my previous variable will be pointing to the previous of temp. Now, after deletion, what is the scenario? So I have to perform deletion operation. I'll just replace this particular value with null like this. Okay, I'll free the memory space. That's all. So for this, you need traversal, you need loop, you need variables to change the link. Very simple deletion. Okay. So did you understand the concept? Are you having any doubts here? Tree is equal to temp of next. Why temp of next? Mari, temp of next. No, the last node is pointed by temp, right? So free of temp is enough and it is not temp of next. If you are speaking about temp of next, then it will be only freeing this null part. Okay, we need to free the entire node, so it is free of temp. Hope you understand, Mari. KYP. Yes. Shall we proceed with the next topic? So now you are going to tell me the logic which is similar to inserting at a particular position. What did we do in inserting at particular position? What was the logic applied over there? Can anyone tell me the logic? What did we do in inserting any element at any position? What did we do? The position was got by the user, right? Position was got from the user. Then, if the position was first position, we deleted at we inserted at the beginning. Then, for reaching that particular position, we need a traversal, right? So we used for loop for traversing. The same logic will be applied over here also. But remember, for deleting, we need an extra variable like previous for deleting. So we need temporary variable that is pointing. When previous is pointing to the first node, my temporary variable will be moved like this. So if the node to be deleted is 30, sorry, if the node to be deleted is 30, okay, then I should make use of my previous pointer. I should change the previous of next to the to point to the temp of next. Okay, that's all. This is very simple. So we'll write code for this and I'll let you know the process. So we are going to now write a routine for deleting at any position. So delete and code POS. So as usual, we'll be passing the address of head here. So we are passing address of head. I'm going to repeat all this process. So I'm just copying it and pasting over it. Delete at the end. So it is deleting at the position. So I will be needing a temporary variable and a previous variable. Temporary variable is assigned to the content of head and previous initially we do not know, so it is equal to null. Okay. So as I've already told you, we will be needing an extra variable for tracking or for the loop. So for I is equal to 0, so you can proceed with this deletion like this. Okay, for I is equal to 0, I less than position. Okay, you should also pass the position here. Position should be got from the user and should be passed. Let us assume my position is 3 here. So I need an extra variable for holding my position. So int position. Okay. So I is equal to 0, I less than position minus 1, I plus plus. So I'll first draw the logical representation. So it is always a good practice to draw the representation and then find out the logic, people. Please do not forget. My drawing is too bad. Let adjust. Okay. Head. Let's have two nodes. I'm deleting at the third position. Let us assume we have 4 nodes here. This 100, 200, 300, and 400. Right? So this is the last node. So my last node's next part will be equal to null. We pointing this node. This will be pointing this node, and this will be pointing this node. Let us assume it as 111x. Initially, it is the first. Should point to the first node with the address 100. So here we go. Right. So let us assume the values 3, 5, 7, and 9. For understanding, let us I'll change my pen color to black now. Now till the address will be 200. address of the next node. Here the address of the next node will be equal to 300. This particular address will be equal to 400. As usual, this will be null, right? So I have what I have done. I have temporary variable initially pointing to my first node. So it is temp. Right? So I have a loop here. My position is 3. I have to delete this particular third node. This is 3. This is 2. And this is 4. So totally I have 4 nodes here. So my third node is the position to be deleted. So let us check here. So as I told you, my what is the work of previous here? Always it will be holding my temporary nodes previous address. Okay, let us. This loop is used for traversing, right? To find the position. So temp is equal to temp of next. I'll explain this now. Okay. So what is the position given? It is 3. Okay. I come inside the loop. I is equal to 0. I less than position minus 1, which is nothing but 2. Okay. Position minus 1, which is nothing but 3 minus 1, 2. So it is coming inside. Previous is equal to 10. Okay. Temp means temp is pointing to the first node. So before making my temp to point to the next node, I should assign to previous. So now my previous will be pointing to the first node now. Okay. Temp is equal to temp of next. So what is temp of next now? It is 200. So 200 will be assigned to temp, which is nothing but temp is pointed to the second node now. Okay. Again, my loop will be traversed. I will be incremented from 0 to 1. 1 less than 2 condition true. Yes. It will be getting inside the loop. Previous is equal to temp. So temp will be now pointed, which is pointed to 200 now will be assigned to previous. Temp is equal to temp of next is nothing but temp of next is 300. So temp will be pointing over here to the third node. Okay. Again, my loop will be incremented. I value will be incremented from 1 to 2. 2 less than 2 condition false, it will be failed. Okay. As of now, people listen. I'll even change my color of the pen and I'll tell you it is no. I'll choose blue. Okay. Now listen, my previous is pointing to my second node and we have reached the position of which user has specified by the variable temp. Okay, my temp is pointing now to the position specified by the user. So we have to make changes in this particular link. What all changes should we do? Now we have to delete this particular node. So I should make my previous of next to point to temp of next, that is 400. So this is the first change which I do. Okay. So what is the first change? I should assign my previous of next. Okay. I should assign my previous of next to what? Temp of value pointed by temp of next. So temp of next is pointing to 400. As you can see, temp of next is pointing to 400. Now 400 will be assigned to my previous of next. My previous is pointing to my second node. So previous of next will now be changed to 400, which means there is a logical connection established between this particular second node and the fourth node. Okay. Now what should I do? I should always free the memory space of an unallocated node, right? So now temp is pointing to the third node which is deleted. So it is, I have to free the memory space. That's all. Okay. So this is how we delete at a particular position. So we have to traverse and this particular loop is for traversing and reaching that particular position to be deleted. Then we have to change the links of the previous node. That's all. So this is how we delete a node at a particular position. So far, we have seen about deletion at the beginning, deletion at the end, and deletion at the particular position. I hope you are clear with the concepts, right? Do you have any doubts over here? you have any doubts, you can pose the doubts so that I'll clear your doubts. So if you draw the logical representation, so it will be very clear for you to write the code. Okay. So in insertion, we were dealing with memory allocation. So what is the statement? What is the dynamic memory allocation function that will be helping us to allocate memory for a node? I repeat, the function that is helping us to allocate memory for a node is what? Malloc. So what is the function of malloc? Malloc will be allocating memory space of specified size and it will be returning the address of the first node. Okay, that address should be holded by a variable. That is the logic of malloc, right? Just because we were dealing with insertion in the last session, we were using malloc, but here we are dealing with deletion. So free will be helping us for deallocating the memory space. Okay, so this is about deletion. So I have bought an assignment for you. Okay, will erase everything. So this is okay. Now it is your chance to find the middle element of a linked list. Okay, so what will you do to find the middle element? Usually in mathematics, how will we find the middle element? Assume that we have 4 numbers or 5 numbers. How will you find the middle element, people? Mid by 2, right? So no, how will you find the mid value? So if you have 5 elements, how will you find the mid element? So you should find the total number of nodes, then find divided by 2 to find the middle element, right? Here also the same logic should be applied. So you have to find the total number of nodes. Okay. So how will you find the total number of nodes? Suganya is talking, right? Suganya, do you have any doubts here? Okay, how will you find the total number of nodes? We have taught you how to find the count, right? How will you find the count? Logic of finding the middle element. So you have to find the count of nodes. Okay. Then you find the middle element, which is nothing but total count by 2. Okay, this is one particular logic. So I want all of one particular logic. There is one more logic applied. So as of now, if you're comfortable with this logic, you can solve this, okay? So you have to find the count, then you find the middle element. So this is the task given to you. This is a program in specified in binary. I want all of you to think and solve this program in the binary platform. So we will be tracking your reports by tomorrow. Your reports are being tracked for placements also. You should remember that. So just because we have taught you all the logic, we want you to solve all the programs in the column linked list. Okay. So if you have any doubts while solving the program, please do use the ask the mentor column and ask doubts in the mentor so that we'll be able to reply you. Okay. So that's all for today. So we have seen about deletion properly in today's session. So if you have doubts, you can ask me. I have also sent my mail ID to you. So you can make use of my mail ID also.